All right, let's dig into something really quite monumental today. Imagine holding a piece of our planet, something that formed when Earth was just, well, barely starting out, a fragment of its earliest beginnings. Today, we're taking a deep dive into exactly that kind of discovery. The confirmed oldest rocks on Earth,
Yeah.
found way up in Quebec, Canada. And this isn't just like an old rock, it's a direct link,
Mhm.
tangible, to our planet's very first mysterious chapters. And as we explore the science, we'll also get into the surprising human story that's all tied up with this find. It's located deep within traditional Inuit lands.
Yeah, and what's really fascinating here is just how much this sharpens our understanding. It's profound, really. These aren't just, ancient relics. They're like geological Rosetta Stones in a way. By figuring out how they formed, they help us unlock secrets about, say, the earliest oceans or how plate tectonics might have kicked off, and maybe even giving us clues about the origins of life itself. It's a direct window into a time we've frankly barely been able to glimpse. Now it's coming into focus.
hmm And for this deep dive, we're pulling insights right from the article. Geologists date 4.16 billion-year-old rocks as Earth's oldest ever. So our mission for you today, listening in, is to explore what these incredibly ancient rocks from the Nuvvuagittuq Greenstone Belt, what they tell us about Earth's first days. Plus, how scientists finally confirmed their amazing age after, well, years of pretty intense debate. And, as I mentioned, that crucial human element tied to their discovery.
Right. And to be specific, this place, the Nuvvuagittuq Greenstone Belt, it's located along the eastern shore of Hudson Bay, northern Quebec. It's remote, definitely, but geologically, it's absolutely critical, a real hotbed for understanding deep time.
Okay, so the big number, the new confirmed age for the intrusion rocks there is 4.16 billion years old. And what's really significant, maybe more than the number itself, is that this figure confirms earlier estimates, ones that were actually slightly older. So it's not just about finding an older rock, it's about nailing down the timeline, finally settling some big scientific arguments.
Exactly. That's spot on. The scientific challenge around these specific rocks, it's been going on for quite a while. Back in 2008, some initial research estimated they could be as old as 4.3 billion years, which ancient. But then other studies came along. They used different dating techniques, you see, and they suggested, well, significantly younger ages, somewhere between 3.3 and 3.8 billion years old. And that's a huge gap, especially when you're talking about Earth's infancy. So this new study, the one led by Jonathan O'Neill from the University of Ottawa, it was just crucial in finally resolving that disagreement.
So how do they actually do that? How do they settle the debate?
Well, the researchers focused on analyzing what they call intrusion rocks. Now, these are rocks formed when molten magma basically cuts through existing rock layers and then cools down, solidifies underground. And they use two different dating methods.
Hmm.
Both are based on the predictable radioactive decay of certain elements.
Yeah.
Samarium and neodymium, I think? That's right, samarium and neodymium. Think of it maybe like this. You have tiny, unstable parent atoms, like samarium, and over billions of years, these parent atoms slowly but very consistently transform into stable daughter atoms, like neodymium. It happens at a perfectly steady rate, like a super precise geological stopwatch, ticking away for eons. So, by carefully measuring the ratio of the parent atoms to the daughter atoms in the rock, well, that tells you exactly when that clock started ticking, basically when the molten rock first solidified. And the remarkable thing, both methods they used pointed to that same incredibly precise age, 4.16 billion years.
Okay, right. And it's important to clarify what Jonathan O'Neill said about this. That 4.16 billion years, that refers specifically to these intrusion rocks, which means the volcanic rocks, the ones the magma intruded into, they must be even older. So that 4.3 billion year estimate from the 2008 study for those volcanic rocks, that's still considered the best guess for their age, which means we're looking at an even deeper history embedded there, really pushing our understanding of Earth's earliest days.
Absolutely. And the significance here is just profound. These rocks, they're specifically basaltic, formed from ancient lava flows, kind of like what you see from modern volcanoes. And they're metamorphosed, meaning they've been squeezed and heated deep inside the earth over billions of years. Yet somehow, they still hold on to their original age information. It's amazing. They give us this absolutely unique window into our planet's earliest time. This puts them firmly in the Hadean eon, that period often called Earth's infant hell, when the planet was still incredibly hot, getting bombarded by asteroids, and the surface was only just starting to solidify from, well, a molten mess. So these rocks, they're like a direct testament to that primordial chaos. They give us incredibly rare clues about how the very first crust formed and help us understand the geodynamic processes happening back then. And what's more, some of these specific rocks might have actually formed directly from minerals precipitating out of ancient seawater, which makes them invaluable, just invaluable for trying to reconstruct what the early oceans were like. Understanding temperatures back then, and ultimately figuring out the kind of environment where life itself could have possibly gotten started on Earth. I mean, imagine that. A rock telling us about the conditions needed for life to begin.
Wow. Yeah, and just to give some perspective here, until this confirmation, the oldest known full rock formations were about 4.03 billion years old. Those are in Canada's Northwest Territories. Now, you might have heard about those tiny zircon crystals from Western Australia. They've been dated to 4.4 billion years. And yes, those are older technically, but it's really important to get the distinction. Those are just isolated minerals, tiny crystals, not like this vast, extensive rock formation in Quebec, which gives us a much, much broader geological picture of that time. Okay, so we've covered the immense timescale, the really clever science behind dating these things. But the story of Earth's oldest rocks, it doesn't just stop in the lab or with geological maps. Actually, some of the most profound questions now involve the land itself, where these rocks were found, and the people who call that land home. Because the Nuvvuagittuq Greenstone Belt lies directly on Inuit tribal land.
That's right. And this has led to some very serious concerns being raised by the Inuit community there. Tommy Palliser, who helps manage the land with the Piktuvik Landholding Corporation, he's spoken out about it. He described how, after some earlier research trips, large chunks of rock were found missing, and apparently some were even seen later for sale online, which is obviously not okay. He's made it really clear that while they understand and appreciate the scientific interest, they just don't want any more damage to the site or people taking samples without permission. So in response, the community has temporarily restricted scientific sampling in the area. Their hope now is actually to create a provincial park. And the idea behind that plan is to carefully balance preservation with, continued scientific access to protect the site, but also allow future studies to happen just under formal guidelines, making sure there's respect for the land and its cultural importance. It's really about finding that crucial middle ground, that balance.
So as we start to wrap up this journey through, well, such deep time and scientific discovery, what does this all really mean for us? Well, I think the key takeaway is pretty clear. The Nuvvuagittuq rocks are now officially Earth's oldest confirmed rock formations. You've got the 4.16 billion years for the intrusions, which supports that even older 4.3 billion estimate for the volcanic rocks they cut through. And they formed way back during the Hadean Eon, that fiery early chapter when Earth was just starting to cool down.
Right. And it really just drives home the significance of these rocks, these basaltic and metamorphosed rocks. They genuinely offer this unique, unparalleled window into our planet's earliest moments, giving us these incredibly rare clues about how the first crust formed, the geodynamic processes back then, all that primordial stuff. And like we said, maybe even clues about the first oceans, the temperatures, the very environment where life might have sparked into existence. It really raises an important question for all of us to think about. If these incredibly ancient rocks offer such unparalleled insights into the very origins of our planet, maybe even life itself, then how do we make sure that the quest for scientific knowledge works hand in hand, respectfully, with protecting cultural heritage and with the stewardship of the lands where these invaluable discoveries are actually made? It's a conversation that connects the deepest past, really, with some of the most pressing ethical questions we face today.